Welcome to Maths with EJD. In this video, we continue with our study on trigonometry. And in this particular video, I'll be talking about special angles. Special angles. There are some special angles that, whenever you're required to use them, yeah, you're not supposed to maybe check for a calculator or check for a four-figure table or a table to get their values, because they are really very special. So there are things you can easily commit to memory, and even if you cannot commit them to memory, you should be able to derive them easily. And what are those special angles? They are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Of course, they are all in the first quadrant, and you can always extend them to other parts. So I'm going to talk about the quadrants in the next video, so you want to watch out for that so you can understand what I mean by the quadrants. Okay, so these are the special angles we'll be looking at. So first off, right? First off, if we take 0 degrees, 0 is really special in the sense that, I mean, maybe there's a proof for this, but I don't want to bother about the proof or how to derive it. Just know that the sine of 0 degrees is 0. Okay? And then the cos of 0 degrees is 1. Then the tan of 0 degrees is 0. Very important. Very important. Now, the next thing I want to do will be about angles. Will be about angles 30 degrees and 60 degrees because they go together. So now this one, I won't just give you the values because we are going to derive it together. Now, for angle 30 degrees and 60 degrees, right? Consider an equilateral triangle. You know, in the first video, I talked about equilateral triangle where all the sides are equal. And because all the sides are equal, right, it means automatically all the angles are the same, 60 degrees apiece, So if this is an equilateral triangle with 2 units on each side, they are all 2 units because they are equilateral. We are taking 2 units, and then all the angles are also equal. Now imagine that you draw an altitude from the top down here. So you draw a height like this, making angle 90 degrees here. So it means this is going to be 30 degrees and this is going to be 30 degrees. So if that is the case, right, it means that you can actually break that down. So you now have it cut off this way now. One half, you have 30 degrees here. Now this is 2. This is also, now this is no longer 2, right? Because this is like, so we are breaking out this half now, So it means this is 1 because, of course, any altitude you drop from the top to divide the other side into 2 equal parts is going to divide that line into 2 equal parts. So if this was 2 before, then it means this side is 1 now. This side is 1. This side remains 2. But now we have 60 degrees. And now this is a right angle triangle. So it means we have this side x. What is side x? Thankfully, we've done Pythagoras theorem in the last video. So from Pythagoras theorem, we can find x, right? Because we know x squared plus 1 squared is equal to 2 squared from Pythagoras theorem. That the sum of the squares of the adjacent sides is equal to the square of the hypotenuse. So it means that x squared plus 1 is equal to 4. That means that x squared is equal to 4 minus 1. So that means x squared is equal to 3. And x is now root 3 units. That is the value of that side. So we can come back and write this now, that this is this triangle now, where this is 30 degrees, this is 60 degrees, and this side is root 3. Then this is 2 units, and this is 1 unit. So based on what we have, so with this now, we can get all the values of 30 and 60 degrees. So let's start with 30 degrees. So if we go for 30 degrees, right, what do we get? So what is sine 30 degrees? Sine 30 degrees is the opposite of 30 degrees. Sine 30. So this is 30. So the sine of 30 is opposite of 30. That is 1. The hypotenuse, that is 2. So that's sine 30 degrees is 1 over 2 or 0.5, if you like. And then we can go for cos 60 degrees, which is adjacent, which is root 3 over or hypotenuse, which is 2. Of course, this is 0.5. And root 3 over 7. Root 3 is 1.732. So this is like 0. You know, 0.866 or something like that. Maybe 8665 or 8664, thereabout, you know. So that is cos 30 degrees. Now check this. We talk about tan 30 degrees now. Tan 30 degrees is now opposite of 30, that's 1, over adjacent, that is root 3, right, like that. So and you can, that can be also evaluated. Let me quickly confirm that. What is 1 over root 3? 1 over square root of 3. 1 over square root of 3. I thought I used to know that offhand. 1 divided by s square root of 3. Okay. 1 divided by square root of 3 is 0.5774. And then square root of 3, square root of 3, square root of 3 divided by 2, just to be sure. Square root of 3 divided by 2. Square root of 3 divided by 2. That is 0.8660. Yeah, 866, 0.866 if you like. So I can stop at 8, I can make it 8660. So that's important. Okay. So then let's see, let's go for angle 60 degrees. So we have 60 degrees now. Of course, still from the same triangle, except that now we are focusing on this. So check. See, sine 60 degrees. Sine 60 degrees is sine 60 degrees is opposite root 3 over hypotenuse root 2. Okay. And then we have cos 60 degrees. That's adjacent of 60 is 1 over the hypotenuse. That is 2. That is 2. Of course, we know this is 0.8660 and this is 0.5. Then lastly, what is tan 60 degrees? Tan 60 degrees is opposite, which is root 3, over adjacent, which is 1. And that is 1.73 to 1.732, I believe. So that's 1.732. Okay, so now from here already, can you see some relationships? If you can already establish some relationships here. So now see, sine 60 degrees is looking like cos 60 degrees. Sine 30 degrees is looking like sine 30 degrees is looking like cos 60, while cos 30 degrees is looking like sine 60. So what can we establish here? Pay attention to the fact that the sine of any angle theta, the sine of any angle theta is equal to the cos of 90 degrees minus that theta. And the same thing goes for the cos of any angle theta. The cos of any angle theta is equal to the sine of 90 degrees minus that theta. What this simply means is that, you know, in trigonometry, right, you need to understand the idea of complementary angles. Complementary angles. Complementary angles. So they sum up to 90 degrees. They sum up to 90 degrees. So what this is simply telling us is that for any two angles that sum up to 90 degrees, the sine of one is equal to the cos of the other. So for instance, check some angles that sum up to 90 degrees. For instance, 20 degrees and 70 degrees sum up to 90 degrees. So that simply means that sine 20 degrees is equal to cos 70 degrees. That's what that simply means. And in the same way now, cos 20 degrees is going to be the same as sine 70 degrees. You can check that out. It's very sure. That is the rule, that's one. What if you take another pair? Let's take another pair that is not so definite. Let's say 33 degrees. What is the which angle complements 30 degrees? That is, the angle that complements 30 degrees is that angle that you add to it that makes it 90 degrees. And that should be angle 50. I believe that should be angle 57 degrees. So I'm sure that sine 33 degrees is equal to cos 57 degrees. In the same way, cos 33 degrees is equal to sine 57 degrees. So that's a general rule with complementary angles. So complementary angles are angles that add up to 90 degrees. So the sine of one is the cos of the other, and the cos of one is the sine of the other. And that's exactly what happens here. So you see 30 degrees plus 60 degrees is 90 degrees. So that is why sine 30 is equal to cos 60, and cos 60, sine 30 is cos 60, and cos 30 is sine 60. So that works all the time for every kind of complementary angle. So that's a very important thing to commit to memory. So we have taken care of angle 0 degrees, angle 30, and 60 degrees. And then let's go for angle 45 degrees. Now for 45 degrees, that comes with a special kind of triangle again. And we'll see that in a moment. So angle 45 degrees. Now, in the case of angle 45 degrees, can you imagine an equilateral, can you imagine an isosceles right angle triangle, meaning that you have a right angle triangle, right, with this right angle 90 degrees, and it is isosceles, meaning that, of course, the hypotenuse is totally different, meaning that now you have these two adjacent sides are equal. And since this is already 90 degrees and these two sides are equal, so it means that the angle facing this side is this, and the angle facing this side is this. So it means that these two angles will be equal. So automatically, this is angle 45 degrees, and this is also angle 45 degrees. So, and since it is an isosceles uh equilateral triangle, right? So it is it is an isosceles right angle triangle. So that means that, okay, let's assume this is 1 unit and this is also 1 unit. Okay, so automatically, if we say this is y, so we can find y, right? Because we know 1 squared plus 1 squared, the adjacent side, is equal to y squared. That means that 1 plus 1 is equal to y squared. And that is 2 equals y squared. That means that y is square root of 2. So it means that we have our triangle this way. It's now 1, 1 root 2, right? And this is 45 degrees. This is also 45 degrees. So based on this now, we can establish all the values. So for instance, if you say sine 45 degrees, sine 45 degrees, if you take this 45, right, that's opposite 1 over hypotenuse square root of 2. And that is, I think, 0.7071 or something like that. Let me be very sure of that. I think it's actually something like that, because root 2 is 1.4142. So we have 1 divided by square root of 2 now. That is, yeah, 0.7071. So if you take this angle also, right, and you take sine, that's opposite 1 over hypotenuse root 2. So it's still the same. So if you go for cos 45 degrees, for cos 45 degrees now, you have, again, you have adjacent 1. So if you take this 45, the adjacent is 1 here. If you take this 45, this is the adjacent. So that's still 1. And the hypotenuse is still root 2. And the answer again is 0.7071. Lastly, what if you take tan 45 degrees? Tan 45 degrees is interesting because it is opposite over adjacent. That's 1 over 1. If you take 45 here, that's opposite over adjacent. If you take this 45, it's also opposite over adjacent. So it means tan 45 degrees is 1. Okay? So now you see, now you can you see the rule again? That rule we established before about complementary angles. Angle 45 degrees complements 45, meaning that they both add up to 90 degrees. And the sine of 45 is the same thing as cos of 45. That's why you see that these two are basically the same. So the rule is applying here again. Okay? So that is another special angle, 45 degrees. So we have taken care of 0, we have taken care of 30, 45, 60. So we have 90 degrees to go. So for 90 degrees, I won't bother establishing a proof. I'll just state the results. So for 90 degrees, right, you should understand that sine 90 degrees is equal to 1. Of course, don't forget that the angle that complements 90 degrees is 0. So you see that cos sine 90 degrees is 1, right? Because cos 0 degrees is 1. Can you see? Cos 0 degrees is 1. So automatically, the angle that complements 0 is 90. So if cos 0 degrees is 1, then the sine of 90 will also be 1. So in the same way, cos 90 degrees is 0. Cos 90 degrees is 0. And that is why sine 90 degrees is 1. So because 0 and 90 complement themselves. And lastly, you have tan 90 degrees, which is also very special. Tan 90 degrees is undefined. If you punch it on your calculator, it gives you an error. So again, you see the fact that, so you see that idea that sine 90 degrees is equal to cos 0 degrees because 90 and 0 complement themselves, and the answer is 1. As you can also see that cos 90 degrees is the same thing as sine 0 degrees. Yeah, sine 90 is cos 0. So cos 90 degrees is equal to sine 0 degrees, and that is also 0 degrees. So you see that for complementary angles, the sine of one is equal to the cos of the other. So we have basically established the trigonometric ratios for all these 5 special angles, and we have also established the fact that for any of the any 2 angles that complement themselves, and by that we mean any 2 angles that add up to 90 degrees, the sine of one is equal to the cos of the other, and the cos of one is equal to the sine of the other. So I can easily tell you that, so I can give you a question that if, so if I give you this simple question that if if sine 35 degrees is equal to y, just something. If sine 35 degrees is equal to y, what is cos 55 degrees? What is cos 55 degrees? So I mean, all you just need to do is to check 35 degrees plus 55 degrees add up to 90 degrees. So, and since 35 degrees and 55 degrees are complementary, that means they add up to 90 degrees. Since they are complementary, what happens? So you can simply say that sine 35 degrees is the same thing as cos 55 degrees, and that is equal to y. So they are both the same value y. Okay, so that's how that goes. So these special angles, anytime you need sine or cos of any of these special angles, it's either you have committed it to memory or you can easily derive it, based on what we have done. So I mean, that's how interesting that can be. So if you have not subscribed to this channel, please be sure to do that. And you should hit the notification bell so you can always get alerted when a new video is released. And of course, like, share, and comment. See you in the next video where I'll be talking about the 4 quadrants. Let's see in that video. Bye.